let's look at a few properties of the discrete probability distributions. So since the x values are going to take on probabilities, then it makes sense that they would have to have a valid probability. So each possible x value has to have a probability that's between 0 and 1. It would be possible here to have 0 or to have 1 or to have any number in between. Another property is that the sum of all of these probabilities for each x has to add up to 1. So you have to include every possible outcome for you to have a valid probability distribution. So if we take a look at example 6.6, where we're looking at automobile manufacturing, and we're looking at the number of minor blemishes on the paint surface. If there's too many, then it's a problem for the customers. So we're going to look at the number of minor blemishes on a randomly selected car from a particular manufacturing plant. If we had collected this from a large number of automobiles evaluated, these would all represent that long-term proportion, and in this case, it's the number of minor blemishes. So if we were to look at each of these outcomes, you notice that they all are values between 0 and 1. And if you add all of these up, you should get something at least close to 1. It's going to be possible with rounding that perhaps it's like 1.001 or 0.999, just because rounding sometimes happens. But you should be able to add this up and end up with the sum equaling 1. From this table, we can answer several probability questions. So we could answer the question, what's the probability that the number is between 2 and 5 inclusive? So we could write that probability that our x is between 2 and 5, and that's going to be found by finding the probability that x is 2 plus the probability that x is 3, x is 4, where x is 5. And so we'll add these up, and we just get these from the table. And the sum of all of those is going to be 0.724. So approximately 72% of the vehicles have between 2 and 5 minor blemishes. Now let's look at another question. What's the probability that there's at least 1 blemish? So that would be the case that x is greater than or equal to 1. That's going to involve 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's an awful lot of addition. I want you to notice, however, what's the complement of that event? So the event at least 1 blemish, the opposite would be 0 blemishes. So it's a lot easier to answer the at least 1 question by doing the complement event. It's just 1 minus the probability that x equals 0. That's going to give you this probability. And so we simply need to do 1 minus 0.041 to get this probability. And that's a whole lot easier than adding up all of those other outcomes.